Box and whisker plots. So here's the thing, you will never be expected to know how to construct a box and whisker plot, only how to interpret it. So previously we looked at how quartiles are calculated, that you need to know how to do. However, we're going to be exploring how quartiles, along with maximum and minimum values, can be represented in picture form with a box and whisker plot. So, these are still the boys and girls marks, and the box and whisker plots are going to look at it. So over here we can see first of all that this is much smaller than this, no matter what the color is. Please take note at how the scale is. It starts at 0 and it ends at 100, and that's dealing with the data. Okay. So over here they're telling us that this little arm over here is the minimum value, which was 40, and this little arm over here was the maximum, which was 84. We have our median value over here, and I would suggest that you write in there that that is also Q2, and that was 62,5. We have Q1, and that was 47,5, and we have Q3, which is 71. And you will notice that the quartiles are all joined. Okay, that's your box part. And we have our whiskers where you take your final ending part and you join it with your max, your first beginning part, and you join it with the box. And these form your little whiskers over here. So if I look at the boys, it's the same. Their minimum is 12 and their max is 96. We have our median over here, our Q1 and our Q3. They've made the box around the quartiles, and they have their whiskers just being joined to the box. So it's not a full box, please note that. The box and whisker plot provides the same information we worked with in example 2, but in an easier way to understand it because it's graphical. The longer the box and whisker plot, the more spread out the values are. And we can see that the boys' marks are much longer than the girls, because we know that the spread of the boys' marks were larger. The length of the boys' plot from the minimum mark 12 to Q1 47 is much longer than the girls. So they're saying this first whisker is quite long as compared to that short whisker. Although Q1 is approximately the same for the boys and the girls, it's clear that the bottom 25% of the boys' marks are much more spread out in the bottom 25% of the girls' marks. Although quartile 1 is similar for boys and girls, the third quartile for the boys is higher than the girls. Third quartile, they're talking about there. While the girls in each sub-range scored similar or consistent marks, the boys' marks varied much more widely. These differences are clearly identifiable by the different lengths of these sections of the box and whisker plots. And then you will go ahead and do exercise 3. Percentiles as a measure of spread. So percentile means we are again working with percent and we're working with 100. So a third measure that we can use to indicate the spread of values in a data set is percentiles. While quartiles divide the data into 4, percentiles divide the data into 100 equal groups. And we dealt with this when we did the growth charts, if you remember that. So over here we have the 10% of data, 10%, 10%, 10%. So if something falls in the 10th percentile, it means the value that lies at 10% in the data set. In other words, 10% of the values in the data lie below and 90% lie above the 10th percentile. So if you are in the 90th percentile, remember we had this argument, the value that lies at 90%, that's what it is, and it means that 90% of the values in the data lie below and 10% lie above. So it means you are in the top 10%, you are in the 90th percentile. We had that discussion. If we look at the median, which is the 50th percentile, the 50th percentile and the median are the same. What does that mean? 50% of the data lies below, 50% of the data lies above. For the third quartile, or the 75th percentile, so these two are interchangeable words, they're the same. So what does that mean? 75% of the data lies below and 25% of the data lies above. So you win the top 25% if you win the 75th percentile, and the rest are below. As with quartiles, we use percentiles to determine the spread of data when the median is used as the average. So that's very important to note. Percentiles and quartiles are used when the median is used as an average, and the median is obviously then included as well into the data sets. However, percentiles are usually used as measures of large data sets. So, for example, the exam results of a whole grade in a school, or all the learners in a province, or even the country. So if we have a look at the example, Kayla wrote the National Senior Certificate Math Lit exam. When the results appeared, her teacher told her she scored at the 92nd percentile of the grade. Kayla is very pleased with her performance, since she scored 92% of all the learners who wrote the math literacy exam nationwide. That means only 8% of these learners scored higher than Kayla. In the same exam, Sabelo scored at the 50th percentile. He's disappointed because although 50% of the learners did worse than he did, 50% in his grade did better. Also note that Sabelo scored the median mark, since the 50th percentile is the median. You will do exercise 4.